Hello, and welcome to Teach Your Students to Program. My name is Crystal Fantry, and I've worked for Wolfram for more than 4 years. At Wolfram, I've led many of their educational initiatives. I also currently work at Beaver Country Day High School in Massachusetts as a mathematics teacher. In this talk, I want to explain to you why it's important for your students to learn how to program, that it is actually possible for high school students and middle school students even to learn this skill, examples of student work, and a way for you to teach your own students how to program. So let's start with the important question. Why? Why should your students learn this skill? So programming skills are becoming more and more of a necessity in this world. As technology continues to grow, most careers at this point have some sort of technology involved in them, and having the ability to program will definitely give you a step up in this world. Of course, they will also be a step ahead in college, especially if they learn how to program in Mathematica, as many of the universities have Mathematica on their campuses. It is known to be one of the most sought-after skills in the job market currently. So another question, is it really possible? The answer to that is yes. I'm going to show you some proof, but I do want you to know that many students who have never tried programming definitely have proven to me that it's possible for them to learn. So let's take this program, for example. This program was created by Taylor McCreary. She's 16 years old. She came to the Mathematica summer camp, and at this program, we taught her how to write code in Mathematica. She had really no programming experience prior to this camp, and she was able to create this fabulous project called NightPass. So how this project works is you pick a square, and then you will see the shortest possible path for that knight to travel. You can also change the number of pawns on the board. So if we do a lot of pawns like 31, you can choose a new square and see what that shortest path is. Now let's look at another example. This example goes through cross-sections of 3 solids. So you can change the shape between a cube, a pyramid, and an octahedron. You can also change the height, so you can see the plane moving through that shape. Of course, over here you can see the actual cross-section. We're able to rotate. And as you see, as you rotate, both figures are moving properly. And this project was created by Matthias Wilder. He's 17 years old, and he also had no to very little programming experience before coming to Mathematica summer camp. Now these are only 2 examples of what is possible. So a little bit more about Mathematica summer camp. This is a 2-week intensive overnight program that is generally held in July. The goal is for each student to create their very own Mathematica project. Students come from a variety of places with a variety of programming abilities. We had students both internationally and nationally. Students came from a variety of different states, and we had more than 300 students apply, and we ended up selecting 33 to come to camp this year. If you would like to check out any of the other projects created, you can easily search for them on the Wolfram Demonstrations project by searching Mathematica Summer Camp. Now to give you a little bit of information about the Wolfram Demonstrations project, there are over 9,000 interactive demonstrations that have all been created in Mathematica. These have been contributed by children, by teenagers, by young adults, by research mathematicians, by research scientists. They can basically be built by anybody who understands how to program in Mathematica. Of course, in order to be published, you must go through a process of the experts at Wolfram. So you can submit your code, and then the experts will look through it and of course probably give you some criticisms back in order for you to fix your code to make it better. And then you go back and forth until your project is actually published. So it's actually a huge deal for them to be published on the demonstrations project. Also, you can go to the Mathematica Summer Camp website. This is where you should go for information regarding next year's camp. Of course, this year you can see it was held from July 7th to the 19th at Bentley University. And all of the FAQs and the About pages are here, as well as the Alumni and Projects page, which will allow you to view our alum from Mathematica Summer Camp and show you the great projects that they worked on while they were there. Now that I showed you that it is possible for your students to learn how to program, how can you bring this to your school? Well, I'm about to show you a new program that we've been working on. So the first part of this is Mathematica Online, which brings programming to the cloud. So all of the computations that you have seen within the programs that were built earlier is all able to be done online now. Also, we are working on creating a curriculum for programming in Mathematica that will actually give you a step-by-step guide on how to learn Mathematica programming. Not only will your students have this guide, but you as a teacher will as well, and you will also have a contact at Wolfram who will be there to answer your questions. So what more could you possibly need? Let's check out the beta program that we're working on and show you how it works. So the plan is for it to be a 10-lesson curriculum, starting with the basics, then learning how to work with plots and list and the function manipulate, of course actual applications, learning how to write functions, a second part of manipulate, functional programming, graphics, and then the 10th lesson is your students creating their very own mini program. So at the top you can see that you can choose through the different lessons. Each lesson will bring up a different notebook in which your students can work through in real time. So if we start with the basics, just give it a second to load. Okay, here we go. So of course this is a beta program, so there will be a couple of issues still, but let's check out the very basics of Mathematica. So of course the first thing you want to learn is how to actually do a computation in Mathematica, which is as simple as Shift-Enter. So within this notebook, although it's already evaluated, you can reevaluate 1 plus 2 plus 3, which of course is going to come back as 6. You can also see that we go through the meaning of a cell, and it will give your students directions on what they should do too. So for instance, create your own notebook, call it practice notebook, and then create a new cell. So in the first lesson, it's the very basics of understanding the language of Mathematica. The second lesson gives an introduction on working with plots in Mathematica. So you can see exactly how to make a plot appear. And of course, a variety of different plots. So your students can try on their own to plot 3x squared plus 2x minus 4 from -8 to 8. And this is what their plot should look like once they do that. We will also lead you into the documentation where many things are answered. Basically, all of the questions you could possibly have about Mathematica are generally answered somewhere inside the documentation center. So through this lesson, your students will be able to not only create plots, but also make them their own and customize these plots. Plotting many lines at the same time as well. In the third lesson, your students will learn all the basics about list manipulation. So lists are very important within Mathematica, so learning them at an early stage will definitely benefit. Of course, a list in Mathematica will tell you is always demonstrated by curly braces. So these are all examples of different lists throughout Mathematica. And then we'll give your students options to write down their own list as well. So each lesson essentially has its very own topic where your students will have the opportunity to follow the curriculum and then prove their skills by actually doing it on their own. Let's skip ahead to lesson 5. So lesson 5 is actually many mathematical applications. So we'll walk through how they're used with numbers. You can find things like divisors and factors quickly by pressing Shift-Enter. And once you press Shift-Enter, you will see that you get back all of the factors of this number. You can also easily find divisors. Sorry for the jumping. And you will see that these are all of the divisors of 9,438. And then from there, you can go through all sorts of other functions within Mathematica. Also learn about factoring polynomials in Mathematica, expanding polynomials, making a small manipulate, and then of course at the end it's always their turn to try and apply what they actually learned during the lesson. The cool part in the 10th lesson is that after your students have gone through all 9 lessons, they will then have the opportunity to actually make their own mini program within Mathematica. So we give them a couple of different programs that they can make, whether they want to explore countries or dynamic geometry. And for each problem, we will actually give them hints on how to get started. So this way, if they are stuck, they'll have somewhere to go. It will be really cool that by the end, your students will be making their very own projects. Of course, we'll also add a couple of videos so that you can have a message from Stephen Wolfram himself, and then a few instructions on how to use the Programming Kids curriculum. So now that you've had a sneak peek at the Programming Kids curriculum, how cool is it? What more could you possibly need to teach your students the basics of programming even without being an expert programmer yourself? This is a programming platform and curriculum all in one, so just one piece that you need. Students will easily be able to follow the materials as they are written so that students will be able to learn a piece and then practice a piece. Of course, teachers will always have us to contact for any sort of technical support, and it's just a simple 10 lessons to get your students started in Mathematica. Of course, after the 10 lessons, if your students want to continue to progress in Mathematica, there are many options for them to continue learning. We have many online seminars about programming in Mathematica, or of course they can just continue to learn on their own. I really hope that all of your students will look at this curriculum and start learning how to program. And if you guys have any questions about it, you should definitely contact Wolfram. Thank you.